All right, let's talk some 2D kinematics. I know I gave you a little bit of a preview of this during our vectors uh, day or lecture, but 2D kinematics is really where we're going with this. Okay, um, so here are some things we already know. Kinematics equations take into account direction. They do. That's what positive and negative, like we said, like a negative velocity, just a velocity in the negative direction. All right, and you can put positives and negatives into an equation. Here's the thing though, what if we go into 2 dimensions and that means we are showing things in terms of angles? Those angles, right, they're not really positive and negative. Who's to say like that direction's positive and that direction's negative, right? They don't, like, I mean, how do you describe those as being positive and negative? What about this dimension though? Like, right, there's all these different dimensions or directions and they can't all be positive or negative, right? They have, that's why we have angles. So we have to use x and y components. Okay? And we can say, well, the x component is positive or negative, and the y component is positive or negative. And the good news is that they function independently of each other. And I know we already watched this video, but I like to watch it because I think it's important here. Which is that, again, right, this is the shoot and drop thing. There's going to be a ball that falls straight down and a ball that's knocked off at the same time. And the whole point is that the vertical part of their motion is identical. Even though the horizontal part is not, the vertical part is identical. All right? And that's what's important. The whole point of this is that, or this is what makes it okay to move things into components, because the vertical and horizontal components of motion don't affect one another. Okay? So, what's the issue? Yeah, we need to do this with all of our vectors. Okay? So, variables. We actually aren't really adding any new equations this unit. It's all the same kinematics ones you already got. Here's the deal. We got a lot more equations. For displacement, we've got x. Oh, not x, sorry. I'm already wrong. We've got r. We've got x. We've got y. And we've got theta r. For velocity initial, we've got v initial, we've got v initial x, v initial y, and the angle of v initial, or theta v initial. For velocity final, we've got v final x, v final y, and theta of v final, and same thing for acceleration. Now, good news is for the acceleration one, you almost never really have to deal with it being at an angle, right? But we have it. And finally, we have time. Time is not a vector, so there's only one value for it. All right, so we have all of these variables, and it used to be we knew we related them with, like, right, with the kinematics equations. Now it's a little bit more complicated, but not entirely more complicated. So let's talk about that. How do we relate these variables? And it's pretty simple. The rules are relatively straightforward. All right. So here's the deal. X values, right? You can use kinematics equations to relate these 5 values. That's basically what we've been doing. For the y values, right, as y values, you can also use kinematics equations. And then anytime you have the same type of, or the same value, so all the displacements, they can be associated, they can be related through trig/triangles. Right? So all of these can be related through trig. Right, this is exactly what we practiced with vectors other day. Now you'll notice, you cannot associate these 4 values. There is no, or even with time, there is no way that they all work together. All right? You can't put them in the same kinematics equation because they might not all be in the same direction. Now, there is a time when they're all in the exact same direction, but at that point, you can do it. But let's leave that aside. That's what we've been doing with 1D kinematics. It's like when they're all in the same dimension. These angles, they're not all the same. Okay, want proof? Look at a throw. So let's say we throw a ball and it goes like that. That's its trajectory. What direction is its initial velocity? What direction is its final velocity? It's down that way. What about its displacement? Right, its r is this way. And even its acceleration, we'll find out later, its acceleration is gravity, so it's straight down. These angles are not all in the same direction. You cannot assume they're all in the same direction unless you know it's going in a straight line. All right? And you can do that sometimes. You can know it, like for example, put something on a ramp and so it slides down the ramp. It's going in a straight line. That's fine. But for those, that's not really a 2D kinematics problem. It's actually really simple. Okay? So we have to stick to using kinematics with these two sets of variables. So what that often means is we start with some of these values and some of these values, and we get them into these x and y values, and then we can do kinematics. Okay? And that leads us to the steps of a 2D kinematics problem. Pick positive, negative directions. I sometimes forget this with 1D kinematics, but you got to do it with 2D kinematics. Like up and down, yeah, usually up is positive, down is negative. But what about right and left? East and west, right? Who decides, is east always positive? Yeah, usually, but like doesn't have to be. Okay, determine what values you know. Okay, what are these 17 values do we know? Any of them that are, and draw any vectors that would be like the hypotenuse. These would be the hypotenuse and these would be the angle, right? And split into components parts. So if I've got these values here, I want them to be these values. Use 1D kinematics to solve those dimensions. Okay, so whatever I do, if I have enough information in x, I solve it here, and then use information from step 4, because I added a step earlier today. Solve the other dimensions. So whatever I get out of 1D kinematics, oftentimes I can use that to do the y part. Okay, and I may have to draw a new triangle if necessary. We'll show that step. Now, these are the 6 steps. You don't always have to do every step, but that's pretty much how they're going to work. Okay? All right, so let's talk about step 2. Because step 2 is the trickiest, I think. Or maybe not the trickiest, but step 2 can be tricky. All right, it used to be we just saw, if you saw acceleration, it was acceleration. But now, if I tell you the acceleration, am I telling you which of these accelerations am I telling you? All right, so let's talk about that. In this case, the car's eastern acceleration was 5 meters per second squared. In this case, I am telling you about AX equals 5. The car's eastern acceleration, that's talking about east and west, which is usually x, and I'm telling you the east and west acceleration was 5. Here, a car's acceleration, I'm just talking about all of the acceleration. The car accelerates. I'm talking about all the acceleration. I'm telling you that A is 5 east, which means that AX is 5, but AY is actually 0. Because again, we're saying that the acceleration is a vector pointed that way, which means there's no up and down to it, or no north-south to it. Okay? For 5 minutes, the car's speed was 20 meters per second. Okay? That just tells me it could be, right, 20, could be this way. All we know is we know that V is 20, or V final probably, right, is 20 meters per second. Don't know if it's the X or the Y part or both, combination. And how long will it take for a car to travel 500 meters north? Okay? That's going to be my change in Y. Right? Assuming Y is north and south, right? Because I'm talking about just the north-south part. I didn't say it traveled 500 meters. I said it traveled 500 meters north. Okay? Now, it could be both. It could be that change in X is 0, but all we know from that is that it's 500 meters north. Okay? Let's do some examples. First one. You walk at a constant speed of 1.3 meters per second, 25 degrees north of west. How long will it take you to travel 100 meters north, or 100 meters west? All right, so first off, I'm going to start it out here that north is positive y, and east is positive x, right? This is step one. I assume most of you will probably stick to that because that's our normal cardinal directions kind of rule. Okay, step two, what values do I know? So I've got constant speed. Okay, so speed, this has got to be, it's constant, so a equals 0, which means that ax equals 0 and ay equals 0. Okay. Constant speed, that's going to be v initial, and it's actually going to be v final. It's going to be both. So v initial and v final are both, sorry, not 25, they're 1.3. All right. And we know theta for this, like theta v initial is 25 degrees north of west. Okay, what else do I know here? And I know that change in x is going to be negative 100. Why is it negative? Right, east is positive, so west is negative. All right, so I've got that. Now I need to know. Now I need to draw triangles. All right, and honestly, like sometimes you'll draw triangles. Like I didn't really need to write this part down. I could have just drawn the triangle and done it. That was the first step. But so, north of west, right? That means I draw a triangle, just going northwest, and I draw north of west means I draw the west part first, and the north part. And this then is v initial x, v initial y. This is 1.3, and this is 25 degrees. And I can get v initial x and v initial y using sine and cosine, right? So sine is opposite over hypotenuse, so sine of 25 equals v initial y over 1.3, and cosine of 25 equals v initial x over 1.3. If I solve for each of them, I get that v initial y equals 0.55, and v initial x equals 1.18. So v initial x 0.18, v initial y 0.55. Well, hey, look, I've got three values in the same x of all the x values, right? And I remember I can connect all the x values through kinematics. Ooh, I made a mistake, a little mistake, not a huge one. This is negative. It's west, right? This arrow is pointing west. Okay, otherwise I was about to get an impossible answer for when I did the math. All right, anyways, now I've got three values of x. I can do kinematics, right? So I've got change in x equals v initial x times time plus 1/2 ax t squared. Negative 100 equals negative 1.18 t plus 0. T comes out to be 84.7 seconds. And that's my answer. All right. Example 2. You are drifting at 2 meters per second, 30 degrees south of east, when the wind picks up and accelerates you at 5 meters per second squared north. What is your x displacement when you reach 10 meters north? All right, so I'm not going to do quite as much as I did on the previous one here with the writing out everything I know. Basically, most of the time, I want to start when I'm doing a problem like this with just the x. I'm just going to really write down the x and y values. Final x, ax, time, okay, change in y, v initial y, v final y, ay. And the reason is all the rest of them are basically going to be just triangles. Anything like, I don't know, or anything like that's a hypotenuse or like v initial or something like that is going to be a part of a triangle. So 2 meters per second, 30 degrees south of east. Oops. You know we got to do this, right? North is positive y, east is positive x. So 30 degrees south of east, that is this way. and then south of east. So I go east first and then south. This is 2 meters per second. This is v initial x, v initial y, and this is 30 degrees. All right. Notice I didn't put the 2 meters per second 30 in my chart. That's okay, because the first thing I know I have to do is I have to split this into x and y components. So I've got sine of 30 equals v initial y over 2. V initial y equals 1. And cosine of 30 equals v initial x over 2. V initial x equals 1.73. 1.73, I think. Yeah, okay. So I just did the trig, and now I've got these two values. And again, this is negative. I got to stop doing that. It is south, so negative, right? 7.3. You look at it, this is clearly going down the negative direction. All right. It accelerates you at 5.5 meters per second squared north. Okay? That means the acceleration vector is straight up. That means the acceleration of x is 0. And acceleration of y is just 0.5, right? It's telling us about all of the acceleration. What is your x displacement when you reach 10 meters north? So my change in what? Guys, why did you let me do this? It's all your fault. This is the one that's negative. It's y that's negative 1, not x. Guys, got to keep me going better than this. Okay? Right? This is 10. So, I want to find what the x displacement is, though. And you'll notice I don't have enough x variables to solve for that. I only have 2. I need at least 3. But I do have 3 y variables. And the nice thing about having 3 y variables is that then I can solve for time. And time is both an x and a y variable. So, I could use the change in y equation, but that's actually going to give me a quadratic, and I don't want to do that. So let's do v final y squared equals v initial y squared plus 2a ay change in y. I've got v final y squared equals 1 plus 2 times 0.5 times 10 equals 11. So v final y equals the square root of 11. Okay. Which is 3.32. And then I can find time using v final equals final y equals v initial y plus at. So I've got 3.32 equals 1 minus 1 plus at. 4.32 equals 0.5 t. T equals 8.64 seconds. Now I've got 3 x variables, and I can solve for change in x. Change in x equals v initial x times time plus 1/2 ax t squared. This whole thing is 0, and I get change in x equals 1.73 times 8.64, or a total of 14.9 meters. A lot of these problems will ask you to solve for time using one dimension, then use it as a third variable for this other dimension. Okay, it's a very common way of doing this. All right, last example. A seed is floating north at 2 meters per second when it gets accelerated 0.2 meters per second east. How fast will it be moving when it reaches 20 meters east? Okay, so I've got the same basic deal. I've got change in x, v initial x, v final x, ax, time, change in y, v initial y, v final y, ay. Again, I really encourage you guys to be doing this basically every time, writing these variables out. At least these 9, even if you're not writing out the full 17. Okay? 2 meters per second. It's floating north at 2 meters per second. Okay, so floating. Floating, that means it's like that's how it's moving. Right? That's our velocity. And I think we're talking about all of our velocity. So if all of our velocity is north, which is positive y, right, then v initial y is 2. And that implies that v initial x is 0. All right? And then we have accelerated, right? Accelerated, this time we're talking about all the acceleration is 0.2 meters per second squared east. So ax is 0.2. And that implies that there's no ay. Ay is 0. How fast will it be moving when it reaches 20 meters per second, or 20 meters east? So change in x is 20. All right, this I want fast. To get fast, I need this fast moving reaches 20 meters per second. So I'm looking for v final, right? Or actually, I'm looking for final speed. Okay, that's my question here. In order to get that, I actually need v final x and v final y. Okay. Now here's the little easy thing here. V initial y, if the acceleration is 0, that's the same as v final y. V final y is 2. I don't know why I wrote meters per second there. But I do need to find it for x. So v final x squared equals v initial x squared plus 2a, change in x. This is unknown, right? This is v final x equals 0 plus 2 times 0.2 times 20. You actually do this out, you get this is 8, which means, oops, this is still squared. V final x equals the square root of 8, which if you're paying attention is about 2.83. Okay, so now how do I get the speed? Speed is referring to the hypotenuse. All right, so I've got this x and y thing. I've got an x component. I've got a y component. 2.83 and 2. And the hypotenuse is v final. Pythagorean theorem. And if I do that, I get velocity final is 3.46. So notice in this one, I didn't do quite as much. I didn't have to do that fourth step. I didn't have to use information from step 4 to solve the other direction. Okay, I didn't have to do that. All right, but that's okay. You don't always have to do it. But I did have to do all the rest of the steps. Okay, so bottom line, split it into x and y. Then do 1D kinematics, then answer your question. And that's it.